Welcome back to Monroe Tutoring, and if it's your first time, well then welcome. Let's learn some stuff. This is part 4 of stoichiometry. If you missed the first 3 parts, go ahead and check them out because the knowledge builds from each part to the next. So let's jump in, and in this part, we're going to discuss being asked for mass of one compound when being given the mass of another compound. So let's think of a word problem. Let's say they ask you, what mass of water vapor will be released from the complete combustion of 100.0 grams of ethane. So, like I taught you in the other sections, I like to extract the information from the word problem and put it very simply stated right underneath the balanced equation. Remember, we need a balanced chemical equation. If you don't know how to balance one, go ahead and check my video out on that. And let's write out the info. So I'm given 100.0 grams of this, and I'm asked for how many grams of this are produced. Now, as I taught you in the previous sections of this, previous parts, in stoichiometry, we're going to need the ratio of the moles of the compounds, okay? So since we're given information about this, we're asked for information about that, let's get the mole ratio of them right away. So there's 2 moles of ethane, so we're going to write 2 moles of ethane for every 6 moles of water. Now, a mistake that a lot of students make is they'll see, hey, I'm being given grams of one thing and I'm being asked for grams of another thing. So can I just write the ratio using grams? In other words, like 2 grams of ethane produce 6 grams of water, and the answer is no. That will give you a wrong answer. Remember, these coefficients are the ratios between quantities of each substance, like countable numbers, right? So in other words, I can say that 2 molecules of ethane react with 7 molecules of oxygen to produce 4 molecules of CO2 and 6 molecules of H2O. Or instead of saying molecules, I can scale that up to moles, right? So I can say 2 moles of this react to 7 moles of that to make 4 moles of this and 6 moles of that, okay? So we have to use a mole ratio in this case. We cannot use grams. We will get this wrong, okay? So let's continue. Now, once we have this written out, we're going to take our given information, we're going to put it to the left like we always do, and that's going to be 100.0 grams, and we always label what the stuff is, of C2H6. Without that label, we're very likely to make mistakes. So, we know we need to use this in order to get from info of one compound to info of the other. But that info is moles of one to moles of the other. But we are not given moles, we are given mass. So as I described in the last section, the last part, well, if we're given mass of this, we need to get to moles of this so that we're able to use that conversion factor, right? If we have mass and we want moles, or we have moles and we want mass, we need the molar mass. Now, I taught you how to do molar mass in another video, so go ahead and check that out if you don't know how to do it. And so I'm just going to skip right in and I'm going to write it out. 1 mole of C2H6 is equal to 30.07 grams of C2H6, okay? So now I can plug that in because I have grams of C2H6 and I want to cancel out grams of C2H6, and this conversion factor has that unit in it. So this part has to go in the bottom so that grams of C2H6 cancel with grams of C2H6. So I'm going to put that down here. So 30.07 grams C2H6. And the other side of the equal sign goes on the top. So that's 1 mole of C2H6. Let's close this off. Let's cancel the mass of C2H6 with mass of C2H6, right? Grams of ethane cancel grams of ethane. If we stop the problem now, we just did this math, our answer would be moles of ethane. But we're not asked for that, so we don't care. We're not going to do the math now. We're just going to keep this going until we have the unit that we want. So let's set up our next parenthesis. Now that we have moles of ethane, we can actually use our mole ratio, right? And this is the part that really makes it stoichiometry, because the mole ratio between the compounds in the balanced reaction is what gets us from info from one compound to info about another compound, and that's what stoichiometry really is all about. the first section of this is really just a mole mass calculation, right? So now we can get to the stoichiometry of it. And so we want to cancel moles of methane. Let's put that part on the bottom. So 2 moles of methane, ethane rather, 2 moles of ethane. And on the top is the other side. That's the 6 moles of water. So if I'm going to cancel my units, and then if I did the math now, what would my answer be? It'd be moles of water. Again, if they asked for that, great, we're done. But they didn't ask for that. They wanted the mass of water in grams. So now we need another conversion factor. Now we have moles, we want mass. What do we use? The molar mass, right? Anytime we want to go from mass to moles or moles to mass, we use the molar mass. But of course, it has to be of the substance that we're talking about. So now this time, we need the molar mass of water so that we can cancel out moles of water. So again, check it out if you don't know how to do it. I'm just going to give it to you now here. 1 mole of water is equal to 18.02 grams of water. And now we can do our third parenthesis, our third conversion factor here, and we can fill it in. Moles of water on the top, so moles of water have to go in the bottom. 1 mole of water, 1 mole of water, and the molar mass has to go on top, or the actual value here. So that's 18.02 grams of water. And now moles of water cancel with moles of water, and the final unit that we have is the unit that we want, grams of water. That's what they asked us for. So let's go ahead and punch this in and see what we get. So we start off with 100. I don't type in the 0.0, and I don't multiply by the ones. I don't divide by the ones. So I'm going to type in 100 divided by 30.07 times 6 over 2 times 6 over 2. You could just type in times 3 if you want. I probably would have done that normally, but you can just read things off of here, and you don't have to reduce anything. You can just go 100 divided by this times this, divided by this, times this, okay? So now we're going to multiply by 18.02, and we get, well, there's a bunch of digits here, but let's look at how many sig figs we should have. That's got 4, this has 4, that's 4. These are infinitely precise, so 4 sig figs. So we're going to do 179, and we're going to round this up to 0.8. So we get 179.8, and that's grams of water vapor are released from the complete combustion of 100 grams of ethane. All right, guys? So just remember, these coefficients correspond to the ratio of moles or molecules between the substances. You cannot just make that the ratio of grams, because clearly there are many other steps involved. If we just wrote 6 grams of water over 2 grams of ethane, we'd miss out on all this important information, and we would not have the right answer, right? So guys, if this helps, please give a like, follow, comment if you have any questions either about this or another video you'd like to see. Save this so you can review again later. And if you'd like to go above and beyond and really help support the channel, you can check out my links. You can patronize me there to help me keep making this content for free. So guys, thanks again, and I'll see you in the next one.